All right, so I'll be talking to you guys about different techniques in which we can have next-gen mobile game development done, and this would be a short 30 minutes. So it might be a little packed with the kind of things that we're looking at over here, but I'll also be doing a small demo, and you'll be able to see a couple of things. So right. So what really makes games awesome? Let's make this a little interactive. What do you guys think by yourself? So can you give them a mic, please? Right. So just pass on the mic. So can someone just answer what does make games really amazing? Huh? Okay, that's actually the first one. All right. And then anyone else? Gameplay. Very good. Okay. Right. So all very good points. Again, it could be how the game is placed altogether. So this is an isometric game in which it was really amazing, and it actually won a lot of awards for it. Um, and have you guys seen this game, Ori and the Blind Forest? It's actually I had tears in my eyes when I actually played this game. So it's about how the story is told and how it sometimes matters if graphics are great. It does matter if the storyline is good, if the gameplay is good. So to aid you in all these things, we have a few technical inputs that we have inside the engine by itself. So one of the first few things that we have is the scriptable render pipeline that I spoke to you guys a little bit earlier about. So the scriptable render pipeline, again, if you guys see this scene from Book of the Dead, you can, sorry, this is pre-Book of the Dead. It's kind of like a small demo showcase that they had. You can see how this scene by itself, it's lit up in its own way. So you have the light sources that are reacting on all the environment objects, and the attenuation of the fog, and you can see how that is, it's volumetric all the way. Or if it has to be like even more, tended towards urban architecture. So this again is a shot in which has been taken, and it shows you how you can actually utilize this power to actually make your scenes look way much better. And I guess a couple of you would have seen the Lexus demo that we had last year, and Lexus actually built a whole animated advertisement using Unity. And this is possible because of the scriptable render pipeline. So what we're interested in mobile game development is the lightweight render pipeline, which is out of preview, and you can definitely see how this thing is. So basically, we have a couple of things that it's optimized for the needs of mobile game creators. So if you have to create a game for mobile or for the web, you can obviously use scriptable render pipeline to make it much optimized. Again, this is open and flexible, and it's customized completely using C hash. So you can write a lot of passes, and you can actually get that in as well. Again, it's scalable graphics. You can have your settings in place as well. You can have a low, medium, and high settings for your scriptable render pass as well. Yeah, and you can interchange between that to basically show you how the graphics can be scaled as well. So for that, I'd like to show you guys a small comparison videos. Have you guys seen Angry Bots, which was one of the older demos that we had? All right. So I'll show you a video over here, which is pre-Unity 5. And in this video, you'll be able to see the older architecture, how Angry Bots was. So this is how it was previously. We had a lot of things. So at that point of time, also the engine looked quite good, customized to its needs. Then again, there were a few things that that were still not in place, like, the real-time shadows, real-time reflections and all were not that performant. But right now, the same game ported into LWRP, oops, ported into LWRP, you'll be able to see how this game actually fares. And this actually adds in a lot of other elements, like, using shader graph and things like that to make it much more performant. All right, yeah. So there you go. You see the differences that are there in the graphic rendering by itself. Okay, we have it's a lot more clearer. You have HDR. You have all this running on the lightweight rendering pipeline right now. And there are a couple of things, like, they have somehow figured out to utilize VFX graph as well. So VFX graph is there in a couple of areas. Really sorry about the spinning sign though. Right. So you guys can see how the same game again ported into LWRP. How beautiful it looks. And as I was telling you, since you can have different asset files that can be, one can be a low settings, one can be a medium settings, and high settings. These can be interchanged on the fly. So you have almost high-end PC kind of settings that you can give for mobile games as well. And at the end of this video, right. So if you guys notice, you can see the pipes. They have some displacement happening. All that is happening with the power of shader graph again. Right? So moving on. So LWRP is out of preview and it's production ready with 2019.1. You can download 2019.1 via the Unity hub, and you can check it out. So it's out of preview. You can check out different features that are there within it, and you can actually ship a game using LWRP on 2019.1. Now, the next thing that I want to talk to you guys about is shader graph and how powerful it is for you guys to utilize it. So this shader graph is basically an extendable tool in which you can build your own shaders. It's a node-based editor that you can do a lot with. So we have a lot of nodes inside the shader graph that helps you do a lot of things. So I'll do a small demo to you guys and show you one of our scenes, which is our entry scene of Unity, the lightweight and high definition render pipeline. So I'm guessing a couple of people are familiar with this who've opened up Unity's lightweight or high definition render pipeline. So what we'll be doing, what I'll be showing to you guys over here is how I'm going to change this walls shader into a procedural shader that has been built by built using shader graph, right? So what I will do currently over here, I'm sorry. Yeah. What I will do is I will create under shader a new PBR shader. Let's call this wall shader. Right? So as soon as you click on this, you'll be able to see open shader graph. And shader graph can be installed via the package manager. Just go into Window, Pacman, open this up, and you should find shader graph under the list over here. If you do not find it, you can go into Advanced, click on Show Preview Packages, and you should get the preview packages to be shown as well. All right? So I'm going to open up this wall shader, which is, it's a basic, so it just gives you this basic node, the PBR master node over here. I'm going to add a couple of things onto this shader node that helps it out. All right. So the first thing that I'm going to do is I'm going to add. So are you guys familiar with procedural algorithms? So there's an algorithm called Voronoi. Have you guys heard of that? Right. So I'll be using a Voronoi algorithm over here. So let's just go into procedural. So under procedural, you should find noise, and under noise, Voronoi. Right. So I'm going to use this. So if you notice, it's like smaller cells that are there inside our graph. And the best thing is, like, you just do some kind of small modifications on it, and you'll be able to see how the noise pattern actually changes. All right. Now, what I want to do is I want to actually connect this with a couple of things that will help it drive it. Okay. And for that, I think you guys must be familiar in while actually building out a couple of games in which you can actually connect things with time, all right? So you connect any property with time, you get to do a lot of things with it. So that acts like an X in your variable, all right? So that's what I'm going to do. I'm going to right click here. I'm going to get my, create a node that gives me the time parameter, all right? So I just type in time, I get the time parameter over here, which gives us a couple of things. Like you have time, which is t, you have sine, and you have cos of the same, okay? And along with that, you have delta time and smooth delta time. So what I'm interested in is connecting it with the cosine parameters, all right? So I'm going to take cosine time, I'm going to take cosine time, and I'm going to put it with the angle of the offset of the Voronoi, all right? As soon as I do that, can you guys notice that, you know, there's a slight movement of the Voronoi pattern by itself, all right? And this movement, again, it's a very subtle movement that I want, and this is more or less exactly like what is required for this current demo as well. So the craziest thing is I connect this to my albedo, which is basically what we usually add textures, and there you go. Our shader basically is moving right now. All right? So along with this, I also want to connect these parameters with, this texture that I'm getting with the emission property. All right? So what I'm going to do is I'm going to invert this right now. So I'll create a node, type in invert, right? I get invert color. I will use that property right now. So let's pull this out and drag it in here as well, all right? And let's invert the channels. So you see, I'm actually getting an inverted channel right now, and this is what I'm going to use. But I'm not going to plug this in directly because I know, this is not going to look that great. So what I'm going to do is I'm going to have a color space conversion as well, all right? So right click, I'm going to create a node over here, type in color space, and you should find color space conversion. Click that and drag this into this, and I'm going to convert RGB to HSV, all right? And as I do that, you notice that it's gone blue, which is kind of like what I was looking for. But if you notice, if I connect this directly to the emission, it's a little too bright, okay? So I want to cut this down a bit, and how I'm going to do that is, it's just simple math. What would you do if you actually want to cut things down? You would divide, right? Or you would subtract. So I'm going to divide over here. So again, you have math properties again that you can use, and under basic, I will find divide. So I'm going to divide this by 2, all right? So I get this in, drop it, and you should find, see, it's dividing by 2 completely. So you can see the differences that are there between both of them, all right? So I'm going to drag out the out and put it into the emission property, and there you go. This looks slightly better, what I would want to use. But this doesn't let me do any modifications in the editor, all right? So what I would like is, I would like to expose a few properties so that I can change it in the editor also. So I'll give a vector 3 for this. Let's call this wall param, right? And let's give default values for this as 4. Right? I drag drop this parameter onto the shader graph that we have, and I will connect this instead of it having its own parameters. So you guys notice that it's already done its work, and voila, I just saved this asset and it's good to go right now. So I close this. Let's create a new material for this. So since we've already created a shader, now we need to create a material for it. So I will create a new material, right? And I will call this wall mat 2, right? And this would be under shader graphs and wall shader. Oops. Wall shader. So this is the shader that we've built, and we have the property over here. Now, what I just need to do is drag drop the shader over here, and there you go. And if you notice, it also took into consideration UVs. So you see the UV is cut in the bottom over here. It actually tiles it very nicely using the whole structure. So if you note, and this is happening completely in real time, and it's very performant as well. Again, it's very good to build moving shaders and any kind of specifics that you want with the help of shader graph, and it's really helpful and performant as well. Um, Yes, so I need to pull this down a bit. If you notice, you're changing all the values as well. And this is just one parameter that I've given. You can basically, you can have a lot of exposed parameters, and all of this can be connected together for you to get really beautiful systems in place, right? So, moving on. That is shader graph, and it's really cool to build procedural shaders as you saw, what we just built was a procedural shader by itself. We can warp, animate UVs, you can quickly tweak and see results in the shader graph window itself. If you guys noticed on the right hand side bottom, we did have a preview window which you could see in real time what is actually happening. And the best thing is you can actually build subgraphs. So this graph that we built, you can actually make this as one graph and use this as a subgraph under another larger node, so, which is really cool. And you can have multiple graphs connected in such sorts, and it's like nested prefabs that we have right now. A lot of them are interconnected. So shaders also will be interconnected, which is really cool. So the next thing that I want to talk to you guys about is the data-oriented tech stack that we have in place. I think we're stressing a little bit on this because it's the future that we know, which will actually drive Unity's editor by itself. So the three things that are basically that are the foundation blocks of it is the entity component system, we have the C hash job system, and we have the burst compiler. So what the dots architecture is going to basically give you is performance by default. No matter what happens, it's just refreshing the data that is required for your computation. So that makes it really performant by itself. It gives you the advantages of multiple cores. Again, if you have multiple cores, building threads for each one of them is going to be really simple using this. It gives you optimized code. Again, you don't need to sit and see where this specific is actually, making your game code get clogged. So when you write something for the dots architecture, it's actually it's optimized code from to begin with by itself. Again, it's the one good thing about the burst compiler is it gives you platform-specific optimizations. So if you write one code and it needs to be optimized for specific platforms, it does it by itself. So this is a small demo that was there. Again, we are shifting most of our components into the dots architecture, and what you can see in this is our new Unity physics that is to be released, and along with that, we are also having integration of Havoc. I bet a lot of you would have seen Havoc's physics run on most AAA title games, and we're really proud to say that we are going to be having Havoc physics inside Unity, and this is possible and optimized using the dots architecture. So if you guys notice, physics by itself, is quite heavy if you have to do it in real time. I think most of you guys would have noticed that or come across that issue. But with the new dots-based physics engine that we have, it's way more performant, and you can do a lot more with it as well. So this is bringing in meshes that have custom colliders instead of it being like primitive colliders, and it's so performant because of the fact that it's running completely on the dots architecture. You would see there are different things that to do with. So this is rubber objects. Again, the density of the materials, all of that is taken into consideration, and it's running really beautifully and smoothly because of the fact that it is performant by default, as I told you. Right? So we have floating objects, and each one of them reacting to their own. So that object basically has a lot of push down factors in it. So if you notice, see, it's actually nicely elevating because of the fact that it's using physics completely on it. So on to the next one. So again, I would like to take this time again to tell you guys that, see, these are a few of the building blocks that can help you in building next gen game graphics for mobile phones. I would urge you guys to start utilizing LWRP, have things like shader graph in place so that you can build your own shaders really fast and really quick, and try to move on to the dots architecture, which can make your games very optimal when it starts off with by itself. So again, there are a few more things like VFX graph and things like that can help you guys out way better. And some of them are in preview, some of them are out of preview. But all in all, I have a feeling that by Q3, you guys would be able to build really next gen, console quality games on mobile using all these things that I've talked to you about. Thank you so much. Any question? We have a question there. Can you give a mic, please?
Hello?
Yeah.
Yeah, so Unity physics and Havoc physics both will be separate or it will be combined together?
Yes, so we have Unity physics that's going to come in. Again, if you want to use Havoc physics, it's just going to be a plugin into the Unity physics engine.
And both will be dots optimized?
Yes, both are dots optimized. It's one of the main reasons why Havoc could integrate very easily into the physics engine, the Unity physics engine. So the Unity physics engine is going to be built out of C hash, and the Havoc is in C++. So you have these kind of optimizations that are there in place as well.
So is it like Havoc will be only available on PC and consoles, or it will be available on mobile as well?
Initially, to start off with, I have a feeling that it's going to be PC consoles, but that would be maybe in the preview mode. But moving on, it's going to be like an integration, like physics, that is going to be used within the engine rather than it being for platforms.
So why to have two different physics engines?
So it's not, we don't have two different physics engines. Unity by itself has Unity physics engine, okay? And Havoc is an extension, you understand? So if let's say you're a AAA title developer, and instead of using the Unity inbuilt engine, you want to use your own custom engine, let's say it's Havoc. Integration of Havoc is going to be much simpler because you have the Havoc integration. That's why Havoc it's a separate package. It's not from Unity. It's basically from Havoc itself. So Havoc's engine is integrated into Unity's engine.
Thank you.
Anyone?
Hello. I just wanted to ask whether shader graph and VFX graph is going to be exclusive for LWRP and HDRP pipelines.
So from ground up, when it was created for the SRP. So shader graph is basically there for the SRP parameters. So if you build your own scriptable render pipeline, you can basically use that. But right now, it is supported on LWRP and HDRP. And we have no support that is going to come for the default rendering pipeline.
Thank you.
Okay, thank you guys. Hope you guys build amazing games. Connector? So Madhur is going to be showing you guys a little more about dots right now, and beautiful demo.